Now, let us see through a couple of arguments that how we can debate on the controversies of how observations presuppose theory, or observations are very pure, or observations are not theory laden, or whatever observation that we make today, they are very much dependent on theory. It is not simply that whatever observation that we make is absolutely pure. Okay? Whatever observation that we make, okay, how it is also mediated by so many other factors. Okay? That is why we used the term perspectives at the very beginning, that a perspective refers to a set of symbols which human beings use to select from all potentially observable aspects of nature. Select. Whenever I talk about perspective, at least three things come to my mind. One is selection and the way we organize our perceptions, and the process of selection and organization of perceptions, they lead us or they guide our actions. Okay? In this sense, we are using perspective, and what kind of perspective that we are going to have, or the kind of observation that we make, are they independent of any kind of perspective? Are they so pure? Are they so indubitable that they are absolutely independent of theory? In this context, we are going to have a section on observations presuppose theory. How? First, let us see observations presuppose some principle of selection. Selection is very important. That is why in perspective we used the first thing, that we do not take anything and everything, we tend to select something. Okay? We cannot, that is why I said observations presuppose some principle of selection. Suppose this is a room, okay? This is a classroom. If I ask all of you to observe, somebody may say that no, there are curtains, somebody may say that no, there is a camera, there is a projector, there is a computer, but I am sure not everybody will be able to capture all observations, all types of observations, all elements of observations. We cannot go on and on observing anything that we come across. In this sense, we make some kind of relevant observations as we feel. In science, it is the problem that decides what is relevant and thus provides the principle of selection. It is up to the individual, it is up to the research problem, okay? It is up to the research question, it is up to the objective of the study, which determines what is relevant and what is not, and thus what is being relevant leads us to the point of principle of selection. Hence, there cannot be observations without a prior problem. To quote Karl Popper, okay, we will discuss Popper a little while later in its entirety. To quote Karl Popper, what he said, before we can collect data, our interest in data of a certain kind must be aroused. The problem always comes first. Suppose in the inductivist schema, science always starts with observation. In the hypothesis schema, science always starts with a hypothesis. In the positivistic schema, science always starts with observation, and in the Popperian schema, science always starts with a problem. Okay? It may be objected that the problem itself is due to the observations that we make, and hence observations come first, but this objection does not hold. Two persons might make similar observations, though only one might come out with a problem. This shows that mere observations will not generate a problem. How then are scientific problems generated? It is important to know. If two or more people make similar kind of observations and only one person comes out with a problem and the other person or persons they cannot, then how then are scientific problems generated? It is usually when there is a clash between what we observe and what we expect. Of the two persons making similar observations, one may come out with a problem, whereas the other may not, because the former has expectations which conflict with the observations that she or he makes, whereas the latter does not have any expectation, or rather the latter has expectations which coincide with the kind of observations that he or she makes. The expectations are generated due to our belief in a theory. Thus, problem generation presupposes a prior theoretical commitment. In other words, a prior belief in a theory is necessary for a problem to be generated, and a prior awareness of the problem is necessary for making relevant observations. That is why as I gave you the example that suppose I will say that my expectation is not to see a ghost, but I am observing a ghost, then I have a problem. Then I create a problem, I create a research question that no, ghosts were a part of that theological stage, not a positivistic stage, not a scientific stage. But if my expectation and my observation they coincide, okay, then there is no emergence of a research question. But if my expectation deviates from the way I make observation, then I tend to come out with a research question. Secondly, in science, observations are taken into account only if they are desirable in a language that is currently used in a particular science. An observation which, howsoever genuine, cannot be expressed in the recognized idiom for all scientific processes or purposes is no observation at all. I repeat, an observation which, howsoever genuine, cannot be expressed in the recognized idiom for all scientific purposes is no observation at all. It is the theory which provides the language or the idiom to be used in describing observations. It is tempting to quote in this connection the words of the physicist and philosopher Pierre Duhem. Okay? And just let me quote Pierre Duhem, the way he tried to capture this, the spirit of this study. Enter a laboratory, approach the table crowded with an assortment of apparatus, an electric cell, silk covered copper wire, small cups of mercury, spools, a mirror mounted on an iron bar. The experimenter is inserting into small openings the metal ends of ebony headed pins. The iron bar oscillates and the mirror attached to it throws a luminous band upon celluloid scale. The forward backward motion of this spot enables the physicist to observe the minute oscillations of the iron bar. But ask him or her what she or he is doing. Will she or he answer, I am studying the oscillations of an iron bar which carries a mirror? No. She or he will say that she or he is measuring the electrical resistance of the spoles. That is why theory provides you with a language or an idiom. If you are astonished, if you ask him or her what her or his words mean, what relation they have with the phenomenon she or he has been observing for a long period of time, okay, and which you have noted at the same time, as she or he will answer that your question requires a long explanation and that you should take a course in electricity. I mean again theory, you come back to theory. I mean observations become null and void, because observations do not give you a language or idiom for expression. Okay. Thirdly, most of the observations in science made with the help of instruments are constructed or designed in accordance with the specifications provided by some theories. And these theories, one may say, constitute the software of these instruments. Belief in the reliability of these instruments implies the acceptance of these theories which have gone into the making of these instruments. Thus, observations presuppose prior theoretical commitments. Okay. First, we objected how observations, I mean observations presuppose theory, how we made objections to this, to such statement, that first we said observations are not pure or indubitable, okay, because of prior theoretical commitments. Secondly, we suggested that observations do not have a language or idiom to express, whereas theories have. Okay. And thirdly, we said that that observations always presuppose prior theoretical commitments. Fourthly, observations in science need to be legitimized or ratified by a theory. We all know that Galileo used some telescopic observations to support his theory. His opponents did not consider telescopic observations accurate. It is not that they did not believe in the reliability of telescope. They had no problem in using telescope for terrestrial of the earth purposes. Okay? They opposed its extension to celestial or heavenly, I mean celestial or heavenly sphere, where things like background, neighborhood, possibility of verification, which are usually found in the normal instances of perception, are absent. They rightly demanded from Galileo a theory of optics which would justify the extension of the use of telescope from terrestrial to celestial sphere. Galileo had no such theory, but he rightly believed that in future such a theory could be formulated. Thus, Galileo believed that it was possible to justify the type of observations on which he was dependent. This instance, if you look at this instance, brings out how observations need ratification or justification in terms of either an actual or possible theory. In this sense too, our observations are theory laden. Okay? Our observations are not pure or indubitable. All this does not imply that observations are theory dependent, whereas theories are observation independent. Earlier we knew that observations are theory independent, whereas theories are observation dependent. Now, now these 4 points that we have made, that observations are theory dependent, whereas theories are observation independent. Okay? Theories and observations depend on each other. Let me tell you that how. All this now implies that positivists were wrong in claiming that observations are theory independent. One just cannot leave either of the two, observation or theory, to to come to a conclusion. Okay? Whereas, each the proponents of each school of thought they went ahead with propounding for either observation or theory. Okay? Thus, no observation is presuppositionless as positivists thought. An observation is not a passive reception, constitution the beginning of knowledge, but involves the active participation of our cognitive faculties characterized by purposiveness, I mean instrumental character, demonstrative character, which we discussed earlier, prior knowledge and expectations. After all, observations are not given, but are made. When I said observations are not given, but are made, that is why observations are not pure, observations are not indubitable as positivists argued, rather observations are always made, observations always emanate from some amount of selection, some amount of perspective, some amount of theory articulation. And when I said no observation is presuppositionless, okay, as positivists thought, because our observation, whatever observations that we make, they must have some kind of theories to back, they must have some expectation to be met with, they must have some objective to make with, to be met with, and so on. Okay? What have we discussed till now? Let us see. Okay? If we look at, I mean last week what we did, we discussed the ontological questions, okay, concerning the relationship between science, technology and society, technological determinism, what kind of problems we are going to face if we subscribe to the idea of technological determinism, then whether technology is neutral or not, how the neutrality of technology is very much contingent upon the ways a particular technology is designed and controlled, then what are the implications of such phenomenon on our economy, polity and culture. Okay? Two profoundly destabilizing changes that we very often witness in the form of cognitive and political. Okay? I mean, when I say political, I mean territoriality, nation states, the question of citizenship and so on. I mean right to food, freedom of expression, right to, I mean accessibility, or the questions of democracy, freedom to dissent and so on. And and then from these ontological questions we move to the more normative structure of science propounded by Robert Merton, one of the proponents of sociology of science and technology perspective in the 1930s and 1940s. He used his functionalist approach to describe the ethos of science, the normative structure of science. Okay? Then he discussed the goal of science as an extension of certified knowledge, the imperatives of science, which include which consist of both goal as well as the methods, technical methods. Okay? I mean empirically confirmed and logically consistent statements of regularities, and from there on we have moved to the four institutional imperatives, four institutional ethos of modern science, namely universalism, communism, disinterestedness and organized skepticism. Okay. In the last week we discussed this. This week what we have discussed? This week we have discussed partly I mean we started with methods of science, and we have tried to cover three important methods of science. I mean two important methods of science so far as the pre-20th century is concerned, and one important method of science so far as the 20th century is concerned. Okay? Pre-20th century, I mean inductivism and hypothesism, and 20th century, I mean positivism. If you look at these aspects, then what we find is that we have discussed how inductivism suggests that the method of science is the method of induction, how hypothesism suggests that no, the method of science is not the method of induction, but the method of hypothesis. Inductivism, the way it was propounded by Francis Bacon and hypothesism by Descartes, perhaps for this reason inductivism is also known as the Baconian model of science, and hypothesism is also known as the Cartesian model of science. Okay? Inductivism is rooted in empiricism, empiricism is rooted in experience, according to which only those ideas which are traceable to sense experience are legitimate. Then we discussed how hypothesism is grounded in rationalism, rationalism is rooted in reasoning capacity, according to which a significant portion of human knowledge cannot be traced to, and therefore is independent of sense experience. And then we discussed how inductivism, in the inductivist schema, science starts with observations, remains at the level of observations and ends with observations, whereas in the hypothesist schema, science begins only when it goes beyond observations. That is why whereas the hallmarks of science in the inductivist schema are certainty and breadth. In the context of hypothesist schema, the hallmarks of scientific knowledge are novelty and depth. Okay? In this sense, I mean how inductivists did not believe in whatever is unobservable, even if unobservable, they did not believe in any theoretical terms like electron, proton, etc. But hypothesists always believed in the fact that no, we must start with a hypothesis and so on, and they tried to look at the real entities and processes involving the unobservable phenomena. That is why hypothesists are called realists, whereas inductivists are called anti-realists. Okay? This is what we discussed, and then how inductivists and hypothesists they prepared grounds so that two rival methodologies can go side by side. Each had their own proponents among both scientists as well as philosophers. And then in the 20th century, okay, what we see the emergence of positivism. As I said, positivism is a stage in the development of society, which has made a transition to come to this stage, having overcome the stages of theology as well as metaphysics. Okay? And then we have discussed the central tenets of positivism in the sense of methodological, I mean that science is distinct from all areas of human activity or creativity, because it possesses a method unique to it. In terms of methodological monism, that there is only one method common to all sciences irrespective of their subject matter. Then inductivism, that the method of science is the method of induction. Then systematic verifiability, that the hallmark of science consists in the fact that all scientific statements must be systematically verifiable. Then we discussed how observations in the positivistic schema are considered pure in the sense that observations lead to theory, but the converse is not true. I mean the unilateral relationship between observation and theory. Observations are pure, that is why they cannot be doubted. Such indubitability the aspect of indubitability was attributed to observations or facts. That is why they positivists tried to look at a dichotomy between fact and value. Facts are value neutral, whereas values do not have any factual content. All scientific explanation must involve deduction, I mean starting from a set of laws followed by a set of initial set of statements describing initial conditions, and the conclusion that we make out of a set of laws as well as a set of statements describing initial conditions. Okay? The conclusion is in the form of a statement describing the phenomenon to be explained, and if any scientific explanation does not follow this pattern, then it is not considered valid or legitimate and is subject to deductive nomologism. Okay? And then the way we discussed that on what count there were critiques to positivistic schema about scientific knowledge production in the form of observations presupposed theory, and then we saw on 4 counts, okay, that we came to know that no observation is presuppositionless as positivists thought. Observations always presuppose some element of selection. Observations are not theory independent, rather observations are theory laden. Okay? What we will do in the next week, that we will start with again with these 4 points slowly and quickly, rather quickly, and then we will move on to how Karl Popper, an eminent philosopher of science, historian of science, how he tried to dwell upon the methods of science by challenging positivism. Okay? And then we will move on to Thomas Kuhn's The Structure of Scientific Revolutions, and then Paul Feyerabend's Against Method. Okay? Thank you.